Sioux Tools has been an innovator in the pneumatic tool industry for almost 100 years. In this video, we will look at the principles of screwdrivers. The operation of a screwdriver is an air motor and planetary gearing used to drive a clutch spindle, producing torque in a fastener. The action of the torque creates clamp load in an assembly. The motor size, meaning horsepower gear ratio, and type of clutch, determines performance and are key factors in the selection of the appropriate tool for a given application. Screwdrivers are generally equipped with a female hexagon spindle to accept standard screwdriver bits. The components of a screwdriver are similar to a drill in that they have the trigger and valve, motor, gearing, and spindle, except a clutch is inserted between the gearing and spindle. This clutch may be a direct drive, positive, adjustable, or shut-off. The clutch is based on the type of fastener and the desired results. The direct drive clutch's output is determined by the stall torque of the motor gearing at a given pressure. When the trigger is actuated, the motor drives through the gearing to the spindle, which stops when the fastener torque reaches stall torque of the motor. The direct drive clutch is simple and requires low maintenance. When a screwdriver is used for driving large to medium screws, the positive clutch's output is determined by the amount of force the operator exerts on the tool to keep the jaws engaged. When the motor torque is reached, the clutch jaws cam out of engagement and start to slip. Torque can be built up in the fastener if the operator allows the slipping action to continue. When a screwdriver is used for driving fasteners where the torque requirement varies due to inconsistent materials, torque accuracy is not as critical. The adjustment of the clutch's output is determined when the tool's preset torque is reached and the clutch cams over the driver cam loads. This causes the clutch to slip, signaling the operator to release the trigger. Torque can be adjusted by changing the amount of spring load on the clutch cams. This is accomplished by turning the tool's adjustment nut, accessible through an opening in the clutch housing. The torque control clutch's output is determined when preset torque is reached and the driven cam and spindle comes to a stop. The driver cam then rotates around the stationary spindle, depressing the pin actuator. This frees the release pin, which moves forward along with the push rod and shutoff valve, stopping the air supply to the motor. The mechanism resets itself when the tool is removed from the workpiece. The torque level can be adjusted by increasing or decreasing the amount of spring load on the clutch cams. Adjustment is accomplished by turning the tool's adjustment nut, accessible through an opening in the clutch housing. When a screwdriver is used on high-volume assemblies where precise torque accuracy is critical, selecting a screwdriver should be done in a systematic way to ensure no details are overlooked that could have an adverse effect on job functions or results. Consideration needs to be given to what is being assembled, what material is involved, what type of screw or nut is being driven, what type of head, what screw size, standard or metric, what bolt grade class, what torque and how is it measured, what torque accuracy is required, is it run-down or seated torque, what type of pull-up, hard, medium, or soft, what pull-up conditions, free run-down, sheet metal, wood, or plastic, what is the production rate, are there any clearance problems, what type of handle, pistol, straight or angled, what type of clutch, what speed is required, does the customer need a reversible option, what type of drive, square or quick change, how is the application being done. Having a better understanding of the basics of screwdrivers will help you help your customers. If you have any further questions, please refer to the training manual or contact Sioux Tools.